In addition to setting standards for the assessment, maintenance, and rehabilitation of underground infrastructure, NASSCO's mission is to assure the continued acceptance and growth of all trenchless technologies. Thanks to the hard work of NASSCO's Manhole Rehabilitation Committee, we are pleased to present this brief video. We also want to thank our sponsors for funding the production of this video and bringing awareness to the many important features and benefits of manhole rehabilitation as a proven trenchless technology. The EPA reports there are over 21 million manholes in the United States. These critical structures serve as windows and access points into our nation's massive wastewater collection system, which includes 800,000 miles of mainline pipe and 500,000 miles of service laterals. This does not even include stormwater collection system assets. Manholes, some of which are over 100 years old, are constructed primarily of brick, block, or precast concrete. Many buried structures have exceeded their useful life due to conditions including temperature extremes, which cause movement due to freeze or thaw cycles, live and dead load, and hydrogen sulfide, or H2S gases, which lead to microbial-induced corrosion, better known as MIC. One of the most notable conditions, however, is excessive inflow and infiltration. Manhole structures can be subject to surface water inflow and groundwater infiltration that contribute to sanitary sewer overflows and basement flooding. Injection grouting can be used to seal out this unwelcome water and to stabilize soils outside the manhole, preventing loss of structural support. The first step in maintaining integrity of this important structure is to assess the condition of the manhole and grade its severity for proper asset management. With NASSCO's PACP as a prerequisite, NASSCO's Manhole Assessment Certification Program, or MACP, provides a common set of coding to identify conditions so they may be prioritized and addressed. Once the condition of a manhole is assessed, the next step is rehabilitation of any compromised sections of the structure. Manhole rehabilitation is a viable, cost-effective, time-saving alternative to manhole replacement. Historically, materials used in manholes for new construction as well as rehabilitation were cement-based concretes and mortars. For rehabilitation, the term cementitious is typically used. Manholes constructed of bricks or blocks have mortar located between the units, while precast and poured-in-place manholes are constructed entirely of concrete. The materials used in the assembly of these structures provided very little protection against corrosion. As a result, mortars and concrete in older manholes are now starting to deteriorate, causing the bricks to loosen and fall out of place, leaving the structural integrity of the asset compromised. Microsilicate mortars are Portland cement-based materials infused with microparticles such as fiberglass rods and pozzolan materials, resulting in higher structural strengths. Calcium aluminate mortars are infused with aluminum dust. The aluminum particles provide some protection against MIC. Geopolymers have similar properties to calcium aluminate mortars for H2S and sulfuric acid protection, but differ as polymerization occurs at the molecular level, creating a cross-linked chain matrix throughout the lining structure. In geopolymer mortars, as additional layers are added, the polymers react to the new layer, eliminating the cold joint. Epoxy coatings are designed for a broad range of chemical resistance, with the ability to bond to concretes, steel, fiberglass, and other surfaces. Epoxies can withstand temperature ranges up to 200 degrees Fahrenheit. They offer protection at high H2S atmospheres and can provide some structural support. Polyureas are a flexible, quick-setting application providing protection against the effects of MIC. Polyurethane solutions provide both structural strength and corrosion protection. Each of these technologies have unique guidelines for installation and surface preparation. Composite liners are a combination of protective linings and mortar, exhibiting different properties than traditional products alone with similar qualities. Cured-in-place manhole liners can be installed as a structural chimney seal or a full-depth manhole lining. These liners are constructed of felt or fiberglass and impregnated with resin. Air pressure is then used to inflate the unit, and then heat is used to accelerate the curing process. Specifically designed products provide complementary or even standalone solutions for manhole repairs. Seals in the form of rubber boots, spray-applied products, or wraps provide solutions that prevent extraneous water from entering the manhole structure. Replacement products in the form of lids, plugs, gaskets, rings, and drop structures can help to sustain the service performance of the asset. NASSCO's Manhole Rehabilitation Performance Specification Guideline is a resource that's been vetted for over a decade. Assembled by contractors, manufacturers, municipalities, and engineers, the guideline details the wide variety of today's technologies and methods for recommended performance-based specifications. Manholes and other structures in the sanitary and stormwater collection systems are gateways to the vast world of buried infrastructure. These critical access points are continuing to age and are in need of periodic maintenance and inspection to prolong their useful lifespan. This is accomplished through proper manhole assessment and rehabilitation methods, saving system owners money as they protect the communities they serve. To learn more about manhole rehabilitation, to become part of NASSCO's Manhole Rehab Committee, to become trained as a certified inspector in NASSCO's Inspector Training Certification Program for Manhole Rehab, and to download specification guidelines, please visit nassco.org. Thanks again to our sponsors for making this video possible.